Welcome to this explainer. Look, if you're building, scaling, or securing modern app ecosystems today, you know firsthand that the complexity of service communication has just absolutely exploded, right? We're no longer just hooking up a couple of back-end servers. We're talking about orchestrating thousands of microservices and AI agents across highly distributed clouds. So today, we're going to untangle this whole web of modern API infrastructure and give you the ultimate blueprint for 2026.
Okay, let's dive into this. Here's our agenda. 1. Decoding components. 2. Gateway versus service mesh. 3. Architecture for 2026. 4. Avoiding API mistakes. And 5. APIs as a product.
Section 1. Decoding API infrastructure components.
Before we look ahead to 2026 trends, we really need to make sure our foundation is rock solid. So let's start with a really fundamental question. What exactly is a reverse proxy? If you look at modern system design, you've got proxies, load balancers, gateways. It is a recipe for total cognitive overload, honestly. So let's just strip it down to the basics.
A reverse proxy is essentially your middleman. It sits right between the clients and your back-end servers, and it receives requests on behalf of those servers. Its main job, to mediate that communication, handle SSL termination, and, maybe do a little bit of caching. Now, a load balancer, on the other hand, is purely a traffic distributor. Its sole purpose is to take all that incoming network traffic and evenly distribute it across multiple servers, usually using algorithms like round-robin or least connections, just to make sure no single server ever gets overwhelmed.
So how does that proxy compare to an API gateway? Well, while a reverse proxy handles your basic traffic routing, an API gateway is significantly smarter. It acts as a single entry point that actually adds essential business logic. We're talking about robust security, authentication, rate limiting, and the whole shebang of API lifecycle management. The gateway doesn't just route the traffic, it completely orchestrates it, manages it, and protects it.
Section 2. Gateway versus service mesh. Okay, so now that we have our front door defined, how do our microservices actually talk to each other securely once you're inside the house? If you've been around microservices for a bit, you have absolutely heard this quote. API gateways handle north-south traffic, while service meshes handle east-west. I mean, this directional framing has been repeated in conference talks for years now. But here's the reality check. That directional framing is fundamentally wrong. Actually, it's a complete myth, and it leads to some incredibly flawed architectural decisions. An internal API gateway can absolutely handle east-west traffic, just like a service mesh's ingress can handle north-south traffic. The direction of the request literally does not matter. It is the underlying purpose that dictates which tool you should pull from your belt. Think of the API gateway as a business-aware manager. It understands concepts like users, billing tiers, API products, and it's totally centralized. The service mesh, though, that's a business-agnostic infrastructure worker. It has no clue what a billing tier is, it only understands service endpoints, retries, and network latency. Plus, it operates decentrally, meaning it injects sidecar proxies right next to every service. And the best part? That requires zero changes to your actual application code. Let's walk through how a service mesh actually secures this communication using mutual TLS, or MTLS. Step 1, the order services sidecar initiates a connection. Step 2, the payment services sidecar presents its cryptographic certificate. Step 3, the order sidecar verifies that certificate with essential authority and presents its own. Step 4, a secure, fully encrypted connection is established. This whole handshake happens automatically. Your developers don't have to write a single line of authentication code, yet you still achieve a perfect zero-trust architecture. It's awesome.
Section 3. Gateway Architecture for 2026.
Now, shifting our focus to the modern build, what's really interesting here is how the role of the gateway has fragmented and specialized. For 2026, we're seeing the massive rise of the triple gate architecture. Organizations are running an API gateway for your traditional REST and gRPC traffic. Next to that, an AI gateway is handling large language model routing and token-based rate limiting. And finally, an MCP, or Model Context Protocol gateway, manages the session context specifically for AI agents securely communicating with tools. All three gateways share a common underlying infrastructure for auth and observability, but they serve highly specialized domains.
Now, for those of you deploying on Kubernetes, there is a massive shift happening right now. We're moving completely away from the traditional Kubernetes ingress resource, which, let's be honest, relies way too heavily on messy vendor-locked annotations, and we're moving toward the 2026 standard, the Kubernetes Gateway API. This new standard offers native header-based routing and, crucially, role-based ownership. meaning platform teams can own the underlying gateway infrastructure, while individual developer teams can own the specific routing rules for their own namespaces. It completely streamlines operations.
And when we talk about operations, we absolutely have to talk about performance. This is why modern gateways have totally abandoned older thread-per-request architectures. A thread-heavy model basically maxes out at around 1,000 concurrent connections per worker, and it eats up massive amounts of memory. But modern, stateless, event-driven gateways using non-blocking I/O, they can handle anywhere from 10,000 to 50,000 plus concurrent connections on a single worker process, all using just a fraction of the memory. The efficiency gains are literally staggering.
Section 4. Avoiding common API mistakes.
All right, we've built this pristine architecture, but now we need to move into the inspection phase. Just to emphasize the stakes here, the global market for API management is projected to hit $8 billion in 2026. APIs are the absolute lifeblood of digital transformation today, which means a single vulnerability or reliability flaw doesn't just break a feature, it directly impacts revenue, data integrity, and brand trust. Getting this implementation right is absolutely non-negotiable.
So, let's blitz through some critical security guardrails. First, do not rely on weak authentication. Use OAuth 2 or JSON Web Tokens with really short expirations. Second, never trust client data. Strict input validation is literally your only defense against SQL injections and cross-site scripting. Also, stop sending verbose error responses. Detailed stack traces are just leaking your internal architecture to attackers. And finally, never ever hardcode secrets into your application. Always use a proper secrets manager environment, for sure.
On the reliability side, the blunders are just as costly. Missing rate limiting? That is basically an open invitation for a denial of service attack. You need to use distributed rate limiting via Redis to protect your backends. Underestimating data caching means your databases are just working overtime for absolutely no reason. Also, inconsistent naming and ignoring standard HTTP status codes create an absolute nightmare for the developers trying to consume your API. Oh, and a lack of versioning? That pretty much guarantees you'll break existing clients the second you try to update your system.
Section 5. APIs as a monetizable product.
For our final section, we're zooming out from writing code to driving the actual business, because APIs are highly monetizable assets. There are 4 dominant monetization models today. You've got usage-based pricing, where clients simply pay per call. You have subscription tiers offering fixed monthly rates for specific capabilities. There's revenue sharing for platforms facilitating transactions, and of course, freemium models to drive that initial adoption. Modern API gateways automatically enforce these models by tracking usage against subscription entitlements and integrating directly with billing platforms like Stripe.
So the crucial point is this. API management is no longer just a developer convenience to make routing slightly easier. It is a core strategic business capability. From the triple-gate architecture managing AI agents to zero-trust service meshes to driving direct revenue, how you manage your APIs fundamentally dictates how your business scales in the modern digital economy.
Which leaves us with one final vital question to ask about your own systems. Look closely at how your organization operates right now. In your architecture, are APIs treated merely as a piece of plumbing infrastructure, or are they managed, secured, and monetized as true products? The answer to that question will absolutely define your success in 2026 and beyond. Thank you for joining me on this explainer, and I highly encourage you to take these blueprints back to your engineering teams today.